Pre-calculus concept 9c, function composition. This will be a bit of a challenging lesson because this is something most of you have never seen before. 4 boxes, we're going to start with the definition. So the composition of the function f with g, the notation you're going to see is this f open circle g, and the function notation that you'll see is f of g of x. That's how this part is read. What you really want to think about anytime you see this is really rewriting it even as f of g of x. So you may notice it kind of looks like multiplication, but it's actually something totally different. We're actually substituting one function, entire function, into the other function. We'll also have to think carefully about the domain, but we'll come back and talk about that. Alright, box 2 gives us two functions and asks us to evaluate f of g of x. So almost immediately we want to rewrite that, because that notation simply means f of g of x. Alright, normally we're taking a number and we're sticking it in for x, right here. But now in this problem we're taking an entire function g and sticking it into the f rule. So here's what that's going to look like. The f rule says take 3 times something and subtract 4. Again, usually we're doing like f of 2, right? But in this case we're doing f of g, and g is a function 2x plus 6. Right? That is the g function plugged into the f function. Simplifying, I get 6x plus 18 minus 4, or 6x plus 14. Okay, that final answer is my composition function. And if we talk about the domain, since it asks us to do that, we want to think about the domain of both f and g. In this case, there aren't any problem values in the domain of g, and also there aren't any for f either, so our domain is simply going to be all real numbers, negative infinity to infinity. Okay, second example, p of q of x. Again, you want to think about this as p of q of x, and that is the q function, right, plugged into the p rule. So the p rule says take 1 over your input. Your input is a function, x plus 3, and that is my composition. When I think about the domain for this one, there's obviously an issue here because I cannot have a 0 in the bottom, and I hope you would see that negative 3 would kind of create that problem. So my domain is going to look like this. Negative infinity, comma, negative 3, and union negative 3 to infinity. That's the same thing as saying all values are in the domain except for negative 3. Box 3 is going to be a u-try. I'm giving you two functions here and asking you to figure out what is f of g of x. I'll give you one hint here. Remember, you're going to think about it this way. F of g of x. Take a minute, see if you can evaluate and simplify that expression. Alright, so again, the idea here is that you're taking the g function and you are sticking the entire function into the f rule, which is over here. And I've got to be particularly careful here with your algebra. The f rule says take your input, square it, subtract 2 times that same input, and then finally add 1. And in this case our input is the expression x minus 3. So starting off you should have something that looks like that. The rest is just foiling, expanding, distributing, combining like terms, and you should have a final answer of x squared minus 8x plus 16. Alright, our last box is the same idea backwards. We can actually learn how to decompose a function that looks complicated, but really is simply two different functions put together. So the key is to think of h of x as a composition of two functions f and g. I think it's the easiest here to focus on what's the inner function, because that's what your g of x is going to be. And usually you have parentheses or something that makes it pretty obvious. In this case, my g, my inner function, is what's inside this radical symbol. And so that's going to be my g function. And then f is kind of like the outer rule. Like, what would you take 2x minus 1 and stick it into? And that's going to be actually not the square root, but the cube root function. Okay, and I could double check this. If I did f of g of x, I'd be taking my g rule and sticking it into my f function. My g rule is 2x minus 1. So, complicated looking functions can often be decomposed into two kind of simpler looking functions. You're going to practice this skill a little bit on your homework.